Hello all, my name is Pooja Santosh Naik and I am from 8th semester CSC in studying in SDM College of Engineering, Dharwad. And we have developed a navigation aid for the visually impaired people. And here is my team details.
Hello everyone, my name is Suman L. Jainpuri and I am studying in 6th semester.
My name is Sambala, I am studying in 6th semester.
My name is Tushar, I am studying in 6th semester.
First, let us move through the contents of the PPT. First, we'll discuss about background, then motivation, project overview, requirements, outcome of the project, conclusion, and references. So mainly the project definition goes, we are trying to design a low-cost, portable navigational aid for the blind people, and this mainly helps for the indoor navigation because right now we have devised a prototype or it's like a foolproof product which is helpful for the indoor navigation, and parallelly we are trying to explore the possibilities of using IoT for the differently abled. So we know that vision is the most important part of human physiology, as 83% of information human being gets is from the sight, and 90% of the blind people they cannot travel independently. So they use either canes, that is 7% of them use smart canes, and 3% use docks. So when you know that blind people, there can be other interfaces which can help them. So one is braille, next is vibration which can be useful for them, but audio is always most preferred. Next, the significance of the project is to help the visually impaired people with appropriate alerting system. And the advantage of the system lies in the fact that it can be proved to be a very low cost solution to millions of blind persons worldwide. So we have already devised a product and we can be sure that it is most affordable one. To go into the details, firstly let us see how it works. And the project can be categorized into main two parts. One is obstacle detection and the other one is once it is detected, how to alert the user. So basically the detection is done by the ultrasonic sensors, and once it is detected, the alerting is done usually through two major means. One is a buzzer which will tell about the sound, and next is vibrators which will give the impression of the feel. So here how it works, we can see a person over here who is walking, and there is an obstacle, the one with the black shade. So here it is considered as an obstacle. Whenever he comes into picture, according to program we have written that whenever obstacle is detected within a range of 1 meter, then the ultrasonic sensor it detects it and it will alert the user through the wrist belt. What we can see, it will alert it. So whenever the obstacle is on the right hand side, it will alert on the right hand side, that is vibration will be done on the right hand side wrist belt. Similarly we have waist belt, so that the obstacle at the waist level can be it can be received, and similarly even we have given a provision with the stick also. Next, the requirements of the project goes, firstly we need a Arduino, that is a microcontroller in which we program, and next we need ultrasonic sensors, and that is to detect the obstacles. We have vibrator motors to alert the user once it is detected. Next we are using wrist or waist belt and piezo buzzer so that there is an alerting system, and LEDs are just for the demonstration purpose. So mainly the outcome of the project is low cost and affordable navigation tool. We stress on the fact that it will be a low cost and it will be affordable to every common man, and it is moreover portable. And along with this we have explored the usage of many hardware components like connecting buzzer, vibration motors, etc. So this is how the product is developed. In the first pic you can see that it is a smart cane which is helping to detect the obstacle. So there we can see that a light is blown. Actually along with the LED we can even feel the vibration with the vibration motors fixed, and even there is a provision of buzzer provided over there. So we can see a LED glowing. That's because it detects the wall which is there nearby, and the LED is glowed. Similarly we have a waist belt through which it will also do the same thing, but it will be tied to the waist, and along with it it will detect whenever the obstacle is detected. So when we have mentioned that it is low cost and affordable, here is a proof. So we can see that the product which is we have already developed, this one, It cost approximately only about 800, and here are the cost details. One is the Arduino board which cost around 500, ultrasonic sensors 80 rupees, waist belt 100, vibration motors, and the cost details go as below. So we can see that as of now we have successfully deployed this model, which is navigation aid for visually impaired people, and as I mentioned, it is very suitable for the indoor applications and is affordable to every common man. But parallelly we are trying these things, so I have put it up as a future scope. For example, we are trying to continue the project in which for the visually impaired, we can see that if we since our product which is already deployed, it is mainly for the indoor purpose. To make it good for the outdoor purpose, what we can do is we can take a GPS. With the help of GPS, we can even use a voice recognition module. So once the source and destination are fixed using GPS, it will help to navigate for the blind people easily, and the basic principle remains same, that is ultrasonic sensors will help to detect the obstacle. And here in terms of alerting system, we are trying to use a voice recognition module which will tell you in terms of speech as to there is an obstacle on the right hand side, don't go that way, and all those things. And there is a speaker, and this can be accomplished mainly with the help of GPS. Nextly, we have a smart insole, and the picture what you can see here, it can be fitted onto the shoes, and the principle remains the same, but it will tell you as to if the obstacle is on the right hand side, to block that way, and it will start vibrating. The right leg sole will start vibrating, and the same case with the left. And here we are using a Bluetooth module, so that we will be devising an app, and through which it will help us. And similarly, these two models were for the visually impaired, smart insole and the GPS tracking system. And next we have something for deaf, that is a gesture vocalizer for deaf and mute people interaction. So here basically what happens is we use an accelerometer. So some kind of gestures will be predefined as to which we use for daily requirements, and whenever some deaf person he encounters this. So next product what we are working on is for the mute people. It is basically a gesture vocalizer. So what happens is basically when mute people they try to communicate using sign language, it is usual that normal people they cannot understand it. So our prototype it basically helps in converting those gestures into speech using a vocal synthesizer. We use accelerometer for the same purpose, and this specially reduces the communication gap between the normal people and the mute people. So already there are few work in this regard. So for example, when it came to visually impaired people, we can see it is there is a guide cane available, then the navigation chair which is fitted with the laptop and other accessories, then we have a navigation belt, and the ultra cane is also available. It uses the sonar for the same purpose. Here we can see there are two left and right hand which can use, and here are the vibrators fitted onto it, and it works with the same principle. And there are other personal digital assistants which can help the people for their navigation. But what comes is all these things are very costly when compared to our solution, and these are the references what we have referred. So basically I would try to end it up saying that we are successful in developing a prototype which is very low cost and affordable by every man. So right now we are working on the products like the gesture control for the mute people interaction, and also the GPS enabled navigation device, and that's it. Thank you.